to discuss one of the most important topic of power system. So we all know the what is the importance of power factor in AC transmission system. So whatever supply we are getting, that is in AC form. So in AC form, power factor is a play a vital role. So these are the outlines of today's class. Definition of power factor, power triangle, and disadvantages of low power factor, and causes of low power factor, and what are the power factor improvement equipments. So what is basically power factor? So at yes, in several books there are several definitions of power factor. In some book there is written it is cosine angle between voltage and current. Yes, it is correct, but of the name suggests this is it is power factor. So it must be ratio of two types of power. So what is actual definition of power factor? Power factor is basically ratio of your active power and apparent power of the system. So power factor cos phi, you can better understand by this equation. So what is cos phi? Cos phi equal to kW divided by kVA. So kW is our unit of active power and kVA is unit of reactive power. So basically power factor is ratio of your active power to reactive, active power to the apparent power. So yes, there are other some expression of power factor is also that is your, it can be also written as cos phi equal to R by Z. So, and or it can be also defined as cosine angle between voltage and current. So these are the some definition of power factor. So most accurate definition is power factor is a ratio of your active power kW or to apparent power kVA. Yes, this is our power triangle. Basically, in power triangle, we are representing all three quantity. As we know, in AC circuit, there are three types of power comes into the picture. That is your active power, reactive power, and apparent power. But in case of AC circuit, in DC circuit, only one type of power, that is your active power. But in AC circuit, there are three types of power comes into the picture. One is your active power, this is your active power, reactive power, and apparent power. So apparent power is you can say vector sum of active and reactive power. So yes, so what is the relation between active power, reactive power, apparent power? S equal to, we can write P plus JQ. So P is your active power and Q is reactive power and S is apparent power. So yes, unit of all those power is also very important. So what is the unit of your apparent power? Unit of apparent power is kVA, unit of active power is kilowatt, or unit of, yes, multiple of unit is also applicable, kilowatt, megawatt, watt, and unit of your reactive power is kVA R. So apparent power is vector sum of P plus JQ. So from this power triangle, if S is, if you know the value of S, then you can easily find out the value of P and Q. So what will be P? P equal to, we can write S cos phi. So this is projection of vector S on x-axis. From this triangle we can find out. Similarly, for Q equal to, we can write S sine phi. So if yes is known, we can easily find out P and Q. Similarly, if P and Q is known, so we can find out S equal to P plus JQ. So mod S equal to, from here, what will be the value of mod S? Under root P k square plus Q k square. So this is the mod Z, and angle phi, how can we calculate? That will be tan inverse uh, Q by P. So these are the, so from S we can find out P and Q, and from P and Q we can also find out S. Next is what are the disadvantages of low power factor? So there are several disadvantages of low power factor. First disadvantage is your large kVA rating of equipment. That means how large kVA rating of equipment we can easily understand. So what I have written, cos phi equal to your kW divided by kVA. So kVA equal to kW divided by cos phi. So if your value of power factor is less, so rating of kVA is more. That means you have, for the low power factor, you have to use larger machine, or you have to design larger machine for the low power factor. So your equipment rating will be larger. This is one of the disadvantage. Yes, greater the conductor size. What we know, P equal to VI cos phi. So what will happen? From here we can write I equal to P divided by V into cos phi. So obviously value of current will be more. If your power factor is less, so cos phi is inversely proportional of current here. So your value of current will be more, and size of conductor will be larger. So if your size of conductor is larger, so what happens? As we know, what is the formula for power losses? I square into R. So your copper losses will be more. And if your current is high, so current is high, that in network, that means your voltage drop across each element which is connected in your system. It may be your transformer, generator, or other equipment, voltage drop will be more. So voltage regulation will be poor. And next point, reduce handling capacity. Reduce handling capacity means we can say, yes, there is more component of reactive power for the same kVA rating. Reactive power in the system is more as compared to active power. So the overall handling capacity of the system is reduced. So what are the different causes of low power factor? First is your induction motor. As we know, induction motor during a starting, it's operate at very low power factor, around 0.2 to 0.3. When it is connected to system, so overall power factor of system is very poor in that condition. And another devices which is responsible for your poor power factor is arc lamps and electric lamp. Arc electric lamp basically. Actually, as we all know, most of load are connected to system are generally in inductive nature. Almost all, in 80 to 90% of industrial load are your three-phase induction motor. And what earlier I have said, induction motor during a starting, it's operated very poor power factor, near about 0.2 to 0.3. And yes, obviously at full load it is okay around 0.8 to 9, but during a starting, uh, during a starting, power factor is very poor. Another is varying load in power station. Varying load, we all know load on the system is not fixed. Uh, Time to time it changes. In morning hour the load is different. At afternoon there is different. Midnight different. Evening is peak hour. So load continuously varying on power station. So at light load period, there is more magnetization current in the system. Light load or no load period. So power factor in that case is very poor. So, yes, obviously the topic is power factor improvement equipment. So, what we are doing for improving the power factor? So, generally we have three conventional devices. First is your static capacitor, another is your synchronous condenser, and third one is your phase advancer. And nowadays there are also more advanced devices like FACTS controller is also used for power factor improvement. But in your syllabus only these three are there. So what is basically a static capacitor? It is a capacitor. Generally, we are connecting capacitor bank in parallel to the line to compensate lagging power factor to a leading power factor. Actually, your capacitor injecting a leading current, what it does, it neutralizes your lagging current, and the overall power system of network is improved. Yes, your capacitor either connected in a star or it can be connected in delta. So how power factor is improving, you can understand from this diagram. Yes, earlier there is a phase difference between your voltage and current was phi 2 when your capacitor is not connected to the system. But when capacitor is connected to the system, now you can see the resultant current is shift some phase closer to the voltage. That means your power factor has been improved. The value of phase angle is lesser than cos value of cos phi will be more. As we know, the value of cos 0 is 1. So near about 0 degree is good power factor. So in that condition, your power factor is near about unity. So you can see from this phasor. So if this phase angle is decreased, that means power factor is improving. So what are the advantages and disadvantages of a static capacitor? First advantage of a static capacitor is your losses is less. Why losses is less? Because there is no rotating part in your static capacitor. That's why losses is very less. Yes, little maintenance. If like your synchronous condenser, there is no rotating part, so there is less maintenance also. Light foundation, yes, there is no heavy foundation required for this. Light foundation is okay because there is no any heavy equipment. uh, Work under ordinary atmospheric conditions. As there are some disadvantage also. A shorter lifespan is around 8 to 12 years. And another disadvantage is when it get damaged, replacement is not economical, and it is easily damaged when voltage exceeds to the rated value. So this is our another power factor improvement equipment, that is synchronous condenser. Synchronous condenser is nothing else, it is synchronous motor. When your synchronous motor is operated at overexcited condition, it behaves as a power factor improvement equipment. So overexcited synchronous motor in all type of motor, in synchronous motor has a unique features. It can operate at any power factor, lagging to unity to leading. So it make a unique feature of synchronous motor. That's why it is used as power factor improvement equipment in your power system network, but it is only economical above than 500 kVA rating. So for lower rating, generally we are not preferring synchronous condenser or synchronous motor. So what actually it does? Basic principle is in both cases are same. It's injecting leading current and neutralizing lagging current, and overall power system of network is improved. So there are some advantage of synchronous condenser. Yes, as earlier slide I have said, it can be operate at any power factor. They, like previous one, in a static capacitor, we can connect and disconnect capacitor in a step manner. But this is a stepless control available in this type of power factor improvement equipment. That means synchronous condenser. It makes more flexible. So high thermal stability, yes, it can also withstand larger value of short circuit current. Fault can be removed easily. Yes, there is some disadvantage. First is, yes, considerable losses in motor. Another one is maintenance cost is high. There is also some rotating part. That's why the maintenance cost is high, and exceeds the rate. So operation is noisy because there is a motor, so operation is noisy, and it is not economical less than 500 kVA rating. And as we all know, there is auxiliary equipment needed for the starting of synchronous motor. So that is also another disadvantage of this type of power factor improvement equipment. So this is all about today's class. Thank you all. In next class, we will study phase advancer.